Megan, one of our mentors, asked me to do a presentation for this, and then made up a title for it, and made up the little blurb for it, and then told me this is the one you're giving. And I went, okay, sounds great. I don't have to come up with one. And then my response is also, wow, that's really broad. We'll see how I can do. So, creativity and innovation in land of building fun stuff. I'll start out real quick with some background on me. I was a FRC kid in high school. The team I was on in high school started in 2005. So 2005, 2008, I was a student on that team. It was kind of nice coming in as a freshman when the team started, because then nobody knew anything, did not have to deal with any seniority issues, etc., because we were all clueless. I was on that team for 4 years and then helped out mentoring for 2 years past that, for 2009, 10, and 11. And then 2012, I helped start 3928 Neutrino at Iowa State and the nearby Ames High School. And then after I graduated from college, I moved down to Texas to work at Vex Robotics. So making largely Vex Pro stuff was the main chunk of my job. And so that had me on 148 and then for a year, and then decided I wanted to have more fun and went down and joined 1296, 20 minutes down the street. And then Travis Shue from 971 actually roped me out here. So now I work with him working on surgical robots up at Oris Health in Redwood City area. During college, well, I've been involved with FRC for a while. I've done a lot of other projects outside of that. During college, one thing I did was a NASA lunar mining competition, which I'll reference once. Lately, I've been doing the Power Racing series, which is building hilariously tiny go-karts and racing them at maker fairs. It's a blast, it is stupid, and it is fun. And then the latest thing, you can catch me occasionally on Discovery's BattleBots. That is out airing right now. So that was my first foray into combat robots. So that is a quick synopsis of my background. Essentially, yeah, I just like robots and fun technical projects and working with cool people on them. So with regards to creativity, internet definition, turns out definition is pretty accurate. One thing that I think this definition kind of misses, and it's partially just also looking at different applications of it with regards to creativity in invention and completely new concept development, and then creativity in the context of creative application of something. So you can take a technology that's been used elsewhere, take it and use it on your problem, and that can be a very creative application of that technology to your problem. So in the grand scheme of things, I also personally tend to consider many robots artistic work, so this just covers it anyway. You're good. But the biggest thing after you're talking about being creative and innovative is why? Why do you want to be creative or innovative? When should you try to be creative? Is it something you want to do all the time, or do you think it can actually hurt you in some cases? And so a couple example reasons why. You're taking it in that, and I'm going to do some of the context, some of the presentation context with regards to FRC, and some just with regards to some other projects. So from an FRC perspective, taking an entirely new problem that existing solutions don't work on, or they could work but they seem suboptimal. So that would be a case of this last year I needed to pick up a cube. FRC robots haven't really done that a lot. There's been a few years where people have came and grabbed totes. So that could be kind of similar. You could pull some stuff from there. And then way back, there were also a different type of tote robots for grabbing. So that was a good opportunity this year to find creative ways to do stuff. And that can be, oh, hey, I would like to use rollers to grab it. I would like to use, I can pinch it this way, this way, this way, this way, top roller, side rollers. Okay, suction cup this side, this side, this side. And just go through every possible way you can think of to do that. But a reason to be creative can get you an advantage, because at this, when they present the game to you, they're giving a very large group of very intelligent people of all of the teams across the world a problem at the same time, and your goal is to go to a competition, face those other teams, and hopefully come out on top. So in some cases, being more creative than them ends up giving you some exponential versus little incremental improvements in things. And sometimes it doesn't help. So in this instance, a real quick instance, this last year, 971 started the season and pretty quick went on, okay, roller calling elevator is probably the way to do this. And then some jerk, me, said, but guys, clearly double jointed arm, it's the way to go. And pulled up a quick put up a quick 2D CAD model and went at it. And one of my biggest reasons why is tucked down at the bottom there. It's fun. And that's also a very contextual thing and I'll remind you again at the end, FRC is about inspiring people and teaching some people when you can and having some fun while doing it. Because anybody who does things and has fun doing it tends to be more passionate about those things, and that passion carries on to other places in life. Other little intricate things for being creative is just fitting something somewhere difficult. Like, I have a box that comes through here, but I need to have this other mechanism nearby it. Okay, creative packaging of here are these parts. I can arrange them this way in order to have it be small enough to fit out of the way to let me do this other thing. So it happens at all different levels. And then one of the more fun ones here is you have interesting resource limitations, money, machines, people, and time for making something happen. One of my favorite instances, and one of the things I think is typically one of the most creative places during the entire season, is actually in the pits at a competition. Because in the pits, money doesn't really do you much good once you're there. You usually don't have much time. Machine access is a little spotty with regards to, sometimes you can get NASA shop to do some stuff and you'll get a little bandsaw drill press action. But the biggest resource you typically have at a competition is people. So when you come out of a match and something's catastrophically broken, you weren't expecting that this is your first regional with a robot, you're still learning it, and you are presented with a problem and you have a limited amount of time to fix it. That set of constraints I've seen force some very creative things out of people with regards to, let's make this happen now. And knowing how and checking and being cognizant of your resources in any situation like that is very, very helpful. I know one instance in 2017, and part of it also happened in 2016, I mentioned before this talk started with regards to the intake on the 2016 robot bent in a match, and that was the first practice match at Champs, and that was the newest rendition of that intake, and just immediately bent, and then they had to get that bent back straight. They went and got Devin from 1678, who was a very creative person with regards to coming up with things that need to work now, and he helped fix that one. And in 2017, we were having some material failure issues on part of our hangar. It was actually coming loose. And the response was, okay, what are our resources? And one of the responses was, I'm going to go get Devin. And Devin came back and helped in a hose clamp later, and everything was good to go again. So that was an example of very limited resources relative to what we could typically do, because you don't have the time to go back home, recat it, recut parts, buy additional parts, etc. You need to solve it then with what you have on hand. And in this case, we went and expanded the pool of people and got some more ideas in flux for it and solved the problem. So last thing for the side, it's fun. There's times to do it, there's times not to do it, but you can have a lot of fun aiming for creative stuff. So I covered a little bit of this, but as far as FRC goes, you can be creative on just your drivetrain, you can be creative on just a specific thing on your gearbox, you can be creative in your overall entire robot. You can be creative in very small ways that do really clean things and make big improvements happen elsewhere. And then you can be creative playing for various gameplays. I'll do one instance. So 2004 was a game called First Frenzy. And at the beginning of the match, above both driver stations, there was big trays full of playground balls. And they started the match up there. And then at some point in time, either during autonomous or later in the match, that entire tray would just dump onto the field. So there was a team that drove underneath that entire tray, unfolded, went like this, caught every single ball that fell down from that, drove over the human player, dumped them all on the human player, really good human player, scored a bunch of points. They were having a lot of success doing this. So they go up in a match at Champs against Team 67, the hot team, who does not do this, but they're very adept at handling these large doubler balls, which you cap on top of goals to double points. So 67's strategy to deal with this very powerful team that's just, oh, I got all the balls, okay. Well, as they start the match, grab one of those big doubler balls, drive right on over, and shove it inside the other robot. Just drop it on top, all right? Your system is not designed to handle that. None of those, all the balls fall onto that robot. They're in there, but they can't get them out. And it was just a very creative, like, okay, here's what resources our robot can do. We can pick up and handle this ball pretty well. Can't quite handle that one. What if we just make them not work by putting that there, and they don't know how to deal with that? And it was a very creative strategy that was enabled with the robot they had, the drive team they had, and the alliance they were playing with, and matched the game. So it was a very creative way to handle that problem. One of the other ones I gave in my earlier talk, example I gave in my earlier talk was in 2002. The game was split up, and it was 4 robots, 2 per side, and 3 large goals in the middle of the field. Those giant hexagons on casters with PVC pipes coming up the sides. I think they weighed like 200 pounds apiece, just on casters. And there were a bunch of soccer balls along the walls. You got points for those goals being in your zone, and the field just taped off with some lines. And you got points for soccer balls being in those goals. So one team went, oh, well, there's 3 goals, and per the points, if I get all 3 of those goals into my zone, I win. Ignoring the soccer balls, ignoring all other things. If all 3 of those goals are in the zone, I win. So they proceeded to make a robot that started out the game vertical, knocked forward, fell down, latched into the center goal, swung some arms out, grabbed the 2 side ones, pulled them in next to it, and then took file cards, which are things made for cleaning files. So it's basically a whole bunch of like 1/4 inch long steel bristles, and made a little drivetrain that just walked. Probably like 1/3 of a foot per second. They essentially took 1.5 minutes to move like 10 feet. Just did that number. And nobody had the traction to stop them. So every match they went, grabbed 3 goals, drove 10 feet, won the match. That's a very creative approach to that game, and it won them championships. They were facing a team once that had a creative response to that, and it was another creative idea born out of constraints. In this case, you're facing a robot that grabs 3 goals and you can do nothing about it. The effect they took was that robot starts vertical, falls forward, lands on the ground, grabs goals. So the match comes up, match starts, human player has a soccer ball, chucks it across the field, so the other robot lands on it and ball bearings to the side and just tries stopping him from even getting to the goals. They still ended up losing, but barely. But it was one of those, that is a very creative way to try beating that robot. And it was born out of a constraint. It was, okay, I'm going to this match, facing this team, can't do anything else about it. What are the options? And that's one of the ones they came up with. So, a few things I'm going to go through here. I essentially took this as part of I could show pictures of other teams' robots, but I'm not entirely, I don't have complete background on all the things developed for that particular project. So I'm going to cover some ones I have been involved with just to be able to give you more of an idea on some of the process that went into it. So 2016, I was with Team 1296, Full Metal Jackets in Rockwall, Texas, and I wanted to make an intake that I could suck in a ball and have it center it. So I wanted to intake the width of the robot, I wanted to drive into a boulder, these guys, and this robot, as you can tell, also has another method of centering a ball, comes in and over. So I wanted to pick up a ball and center it because right in the middle of this intake was a catapult. So I had a thing I wanted to achieve. I had some previous knowledge of other teams that have accomplished this. So like the 2014 971 robot had a set of tusks on the bottom that rotated inwards. So, and the top was just inward spinning roller. So when you drive towards the ball, it sucks it in, and the bottom ones spin to the middle. So it goes whoop and centers the ball right up. So I was effectively looking to do that on a smaller scale with a boulder. I didn't want to dedicate 2 motors to it, via the 971's robot had a motor per tusk, essentially. I didn't want to have to do that, so I was looking to combine stuff. So I ended up actually taking, and wanting to make this very compact, because this is a lot smaller than a giant trackball, so the system I want to deal with is much smaller. But there's a trick I had learned in the past with regards to some creative uses of other things. But I'm taking it most of you guys have probably touched at some point in time 1/2-inch hex and 3/8-inch hex as a shaft material for a robot. In this instance, I wanted everything to be really small and my torque requirements were not that high, so I chose to use 1/4-inch hex. I can go buy mild steel 1/4-inch hex off McMaster, but in this instance, I did want to be a little stronger than that, so I actually went and bought a whole bunch of 1/4-inch T-handle Allen wrenches and used those as axle stock. The attempt was essentially roller, 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 roller. I wanted these 2 spinning that way, those 2 spinning that way, and I wanted 1 motor to power all of it. So what I ended up doing was I bought some DeWalt right angle drives, which are just commercial off-the-shelf little things meant for getting screws in tight places. And that happens to have a 1/4-inch hex input and a 1/4-inch hex output. Already made for you. So I find out if I pop this apart, there's 2 little bevel gears in there with 1/4-inch hex through them. So between those and those Allen wrenches, I was able to have 1 single back shaft that comes along this entire tube, and then 4 smaller stubby shafts, and then bevel gear set, bevel gear set, bevel gear set, bevel gear set, and I turn 1 axle at the end, and this is a piece of 1-inch steel tubing actually. So I was able to have 1 motor turning that, and this all runs. And doesn't really take up much space, very tiny, very durable, because it's just thin wall steel tubing. This was a prototype that was pretty close to working, but it was too aggressive. It would take the ball, suck it to the middle, and then start spitting it out the bottom, as far as taking it and then just mushing it out the bottom. So that was kind of annoying to deal with. We ended up actually not using it at all and switching to a printed spiral roller and letting the ball rotate, which is much more similar to the vectored intake wheel setup this guy has. But it was basically a creative application of off-the-shelf components as far as product availability. The NASA Lunar Mining Competition thing I mentioned earlier, we had one instance, it was a couple days before leaving for competition. We were doing some testing, and we had a 70-75 1/2-inch hex axle just bend on us. And it was a more significant cantilever than we would have liked, but our options were limited, and we couldn't find where to buy any 4140 hex, a steel hex, anywhere. But we ended up at a hardware store wandering around grabbing some tools before leaving on our trip down to Florida for the competition, and another teammate pokes me on the shoulder and says, "Hey, you know where you can get some steel 1/2-inch hex?" and points at the shelf full of stuff at the giant 1/2-inch T-handles, Allen wrenches. And it's like, okay, you're right. And then went and made an axle real quick out of an Allen wrench. And 0 problems, worked great. All right. So looking for existing things that are, like, industry has solved many things for you and also has made many things available in further along states than just raw material. And that's an example of applying some of that. So some of you saw me driving around a silly little go-kart earlier. This was actually a thing I did for the very first one of those I made. I wanted to have a 2-speed. So I could have, and part of this, that competition has you operate at a $500 budget, so you need to keep track of what you do use. But the product on the left is a thing I actually helped develop at Vex as a ball shifter cluster. So it's part of a standard off-the-shelf 2-speed ball shifter. So how this works is there's a central plunger, and then there's a set of balls that engages this gear, or you push it and engages this gear. So you pick between those two. And typically the motor is up above, driving a gear coming down through here, and this is the output of this system. The shaft picks which gear to drive, and that goes down to your drivetrain. In my instance, I wanted to have 2 chain runs going to my back axle, and I could just use a bigger sprocket and a smaller sprocket for my 2 different speeds. Now it was real cheaper to make because I could just machine them myself, or even buying plate sprockets is a lot cheaper. And also more flexible with regards to swapping them out quickly and not having to worry about center distance changes. So in this instance, I took these existing gears, popped them in a CNC machine, and made them sprockets. So I now had a ball shifter shaft where the output was now the input, and I had 2 chain runs to my back axle. And that one actually ended up having some problems with regards to shifting under load, because for first robotics robots, you are accelerating forward and reverse a lot, so you often have some dwell time, so shifting is not that big of a deal. But when you're accelerating hard and wanting to shift, you need to release that system from load and get things lined up in order to go. So mechanically it was fine, but during actual operation, getting it to engage cleanly at that speed was really hard. So I ended up using a different method I'll get to on later. But just another instance of repurposing an off-the-shelf thing as opposed to starting from scratch. I'll pass this one around up here. Play with it. Who knows what a swerve module is? A couple of you guys? So when you go buy, if you get a kit of parts chassis in your kickoff kit and drive, it's a 6-wheel drive tank drive, which is referred to as a differential drivetrain, essentially. Because the output of that system is right side, left side, you have 2 degrees of freedom, and then you get translation and rotation. If you want to drive forward, both sides drive forward, backward, spin one the other way, you spin in place. In the case of swerve drive, you end up putting some number of these modules on a robot, but all your wheels can turn independently. So you can do all sorts of fun stuff like driving a straight line while spinning, sit there, point sideways, and drive sideways. Lots of options are available. This drivetrain's been around since like 1999 or something, but often it was a fairly bulky assembly that took up a lot of space. And 2012 was the first year of Team Neutrino, so we were rookies actually. And we're stupid and went for something creative and fun and built this module. And I posted this picture on the internet, and it took people a fair amount of time to realize where the motor that drives the wheel was. And it took people a while to realize that this right here is the exposed face of a sim motor. But basically what this enabled was everything was much more compact, and there was less stuff, so it also ended up being significantly lighter than many of the other modules. It had its own pitfalls with regards to manufacture, as far as some additional complexity, but it basically shrunk everything, because that robot was actually, I think, 7 inches tall, and for the most part fit underneath the bridge that year, for anybody who's familiar with 2012. But in this instance, there was a sim driving the wheel, and then a little BaneBots 395 through a gearbox over here for steering that unit. The most creative part of this module to me is not the fact the motor's inside the wheel. It is actually this tensioner. So we were faced with a problem. We had a belt run here, and we also had a gear run back behind it that were both in the same center. Gears aren't really flexible. You want them to be at a fixed center, and you can't just adjust them up and down. So I needed to tension a belt, but I couldn't change my center distance spacing, which is what's most commonly done in FRC. So I needed to put a tensioner in from the side of the belt to push on it. So in this instance, we were able to solve this problem by adding a screw and 3 bearings, completely off-the-shelf parts, and the module also had a clamp. So I took one of the standard mounting screws, mounting screw holes in the face of the sim, put a screw and bearings on it, and then if you look at the back side of the module, there's just a little hose, basically a little shaft collar type clamp on the sim. So you'd loosen that clamp, rotate the sim until the belt's nice, lock the sim down, done. So we were able to get functionality for very, very little. Like, I didn't have to manufacture anything new. I didn't have any, there was no extra package out here that increased my swing radius. Like, it was just the simplest little thing, I think, is easily the most creative part of this entire module. So another fun one. So I don't know who's familiar with a butterfly drive. Okay, I got one of you. All right, so 2013, the year after the swerve, we went, okay, let's go a little simpler on the drivetrain, but still not what we should do. So let's still do something else fun. A team that I was later actually on, 148 in 2011, did what's known as a butterfly drive, which is essentially 4 omni wheels and then 4 traction wheels, and the ability to switch between the two. we decided we wanted one of these, but the existing modules that like 148 had made were very substantial in size and had some durability issues. So we wanted to make our own, but we wanted to match it to our manufacturing capabilities, which were different than them. They had a very advanced sheet metal shop that would crank things out and made it largely transparent. We had a whole lot of manual and some CNC machinery available. We wanted to optimize it for maintenance if it ever needed it, and we wanted to streamline manufacturing to match our expectations. So this module, the creative approach here was essentially, what do I actually need? I need power for each side, so I had a motor. I had an omni wheel, I had a traction wheel, and I had an actuator to switch between the two. I needed a gear reduction between my motor and my wheel, and I also wanted this guy geared even lower, so as the traction mode, I had more pushing power. So effectively give me a 2-speed too. But if you look at it, you realize if you take any single one of these parts away, the system doesn't work. There's no superfluous parts. So in this instance, everything, we had to manufacture them in a lot of parts. All the parts are pretty simple two-dimensional parts, nothing crazy. There's one more fun part here with CNC because we could and had the ability to. But we also managed to take this whole thing and house it inside a piece of 3x3 tubing, so I could just buy a piece of tubing as opposed to making it have some sheet metal frame around it. And that simplified some things, and then it also supported the module. And one of my favorite parts from the optimized maintenance perspective is in order to pop one of these modules out, you popped a spring off on this little tab, and you pulled a bolt out, and the module dropped out of the bottom of the robot. We had one instance where people are coming around in the pit, and our demo module was with another person, and somebody wanted to see one of our modules. So I turn, pop out my pliers, pop off the spring, pull out a bolt, pop one out of the robot, show it to them. And they're staring at me like I'm nuts, because I just took apart my robot to show them a thing. And then popped it right back in. Like, it was that simple to pop it in and out. I'm pretty happy with how it happened, but this was an exercise in distilling it down to what you actually need and how compact can it really be. So I'm going to pass that one around too. Another fun thing about that one, the side plates of that module are 1/8" steel plates. As many of you know, steel is not a very common material in FRC. I actually got some ribbing from my coworkers down in Texas, / the originators of the butterfly drive, about my heavy steel side plates. To shut them up, I went and opened their CAD model, opened the aluminum, custom fancy sheet metal aluminum enclosure around the module, isolated it to just that, mass properties, all right, weighed the exact same. So I was using steel from a durability perspective because it was very small and I had some concerns. But I used less of it and everything was smaller, so it was a wash and they stopped giving me crap. So that was more of a, don't just, the lesson there is more just like, you're allowed to question things and use other materials. Like a lot of stuff happens on autopilot in FRC. So this one's not done yet, but it's been a very fun one. And this is another thing, solution to a problem nobody really has. But I decided one was there, so I started poking at it. So in FRC, you have a power distribution panel with 16 spots on it. You have a limited amount and type of motors you're allowed to use. They started making unlimited recently. But there's a motor called the 775 Pro motor, which I worked on at Vex, and they're very powerful motors, but they don't have much for thermal mass, so they don't handle abuse very well. So drivetrains are classic high abuse points. So in this case, I went, okay, if I wanted to do a swerve, I would like to make it tiny and light and not use a sim per. Like, if I could figure out a way to use 2 775 Pros per module, that'd be 8 of my drivetrain, I'd be great. But if I were to do that on a conventional swerve, like the motor and wheel one I passed around, there'd be 1 motor powering the wheel and 1 motor steering. So the 4 driving me around are taking a lot of load and not sharing it very well. You know how I described earlier the 6-wheel drive tank drive is referred to as a differential drivetrain? If you take both motors, drive them the same speed, same direction, you move in a straight line. Same speed, opposite directions, you spin in place. This module is purely that contained mechanically. So, and it happens at the module level. So this top gear, 1 motor directions, my wheel stays straight, but spins. If I vary the speed of them at all, the whole module steers. So I have two inputs, my two drive motors, and I get 2 degrees of freedom out of that. I'm spinning the wheel, and I'm steering the wheel. So this would essentially let me take both of those motors and have both of them delivering most of their power to moving my robot across the field. So I split my load up among 8 775s, and that seems reasonable. We have not yet finished this guy. We got distracted by some other things. But you can picture this module with 2 775s next to it, and that whole thing is about yay big and will probably weigh like 4 pounds or 5 pounds. And then you have a drivetrain that takes up next to no space, weighs very little, a lot of room for other activities. So, and there's some details in this one that help minimize part count, because once again, if you notice, you take away any part of this, it doesn't work. It's distilled down to only what's needed. So, all right. This is one of the farther off the wall ones. So, anybody not familiar with the 2015 FRC game called Recycle Rush? Effectively, there were 3 robots on each side of the field. There was a border in the middle. You couldn't go from one side to the other. And there were a couple of game pieces that started in the middle that were large recycling containers. And so if you wanted to win at higher levels, you needed to grab those and bring them to your side, but you're racing somebody to do the same on their side. So it's a game of how fast can you get 2 recycling containers and get them back away from the other people. A couple days before Champs, I decided I wanted to build some suction cup crossbows, because why not? And in this instance, the solution to this problem is essentially, if I'm sitting there behind a line, there's some trash cans over there, and I want to get to them, it's effectively how much energy can I put into something, and how light can I make it. If I have a car and I want to go faster, one option is take out weight, because then I accelerate faster because I have less stuff to get up to speed. So in this instance, I was looking to minimize weight, so I had a suction cup and an actual crossbow bolt. This is why I reinvent the wheel. So it had the same little tang on the back and everything. I took some Vexpro parts and then some Vex EDR parts, actually. And then this is spear gun tubing, because there's already a commercial off-the-shelf thing out there that does this. And I just went and used it as well for launching spear fishing. And then I went, how am I going to release this quickly? Oh, hey. People have already solved that too. Here's an archery trigger. Just went and bought that too. Like 20 bucks at Bass Pro Shops or whatever. And then I ended up having a little electromagnet set up to pull and release that. So match starts, 3, 2, 1, ka-chunk. Fires 2 crossbows into cans. And they're really hard to get off. It ended up getting stuck on a 4th robot, a backup bot for an alliance, in another division after we were out. But they got knocked out before I saw the field. But it still existed, and it took like 2 days to make. Because this was actually all mounted on a little ball and socket camera mount. Like I went on Amazon and bought a camera positioner in order to mount this on, so you could set down the robot and then aim them individually and lock them down. Because someone's already solved that problem too, rather than doing completely custom brackets. So. This is a fun BattleBots related one. I was working on a prototype, and it was basically another creative solution born to constraints. In this instance, this is the bottom of a single piece billet chassis. So FRC used to bolting a bunch of metal together to make a chassis to a robot. In this instance, this was made out of a 20 by 20 by 3.5 inch thick solid piece of aluminum, completely milled out. You need to be really durable for BattleBot stuff. And turns out making a brick works. But in this instance, I had cavities for the bare minimum of stuff. So I had batteries, speed controllers, wheel, and then my central launcher mechanism, which was a choo-choo, for anybody familiar with that from FRC stuff. And I had, on the choo-choo, I had a sprocket here, and then a sprocket here, and then 2 smaller sprockets. So I needed my power output here, but I only had this space for motor and transmission. So typically, if you are on a robot, you have a motor versus planetary output. It's motor, gearbox, output. If I were to do that same setup here, it'd be motor, gearbox, sprocket. A sprocket there doesn't do me very good. Like, I need it here. in order to fit into the middle. So this was effectively a packaging problem of, I have a motor, I think I needed like a 16 or 28 to 1 reduction territory. It was a 2-stage planetary I really needed. And then I had 2 chain reductions after that, but I needed the output in the middle of the gearbox pretty much. So this was a fun one and took a lot of pondering, but I did find a solution. In this case, this is a hobby brushless outrunner motor. There's a motor shaft down the middle, and this shaft actually goes through everything. There's a sprocket, there's a planetary stage, there's another planetary stage. So the shaft on this motor goes straight through, and then the sun gear powering the planetary is on it. So then it powers this carrier, which then goes to this sun gear, which has a hole through it that this is all clearance on. And that powers this guy, which powers the sprocket, and the chain comes out the side. So I have a motor, a gearbox, and my output just flipped from usual. And guess what? This arrangement is used elsewhere in life. So that's just a little video of it going. And the input of the gearbox is over here, motor's over there. And then there were 2 more chain runs that came down from here to the final drive. But turns out this layout is often used in electric winches on the fronts of trucks. They essentially want to have a big drum, and they don't really want a gearbox and then a motor all hanging off one side, because people like symmetry. So if you're staring at the front of a truck and you see a giant thing coming on one side and then a spool and then nothing, it doesn't look good. So a lot of them actually ended up coming up with motor, shaft through the middle, gearbox back the other way, winch spline, well, winch drum, and same thing. So in this case, I just packaged it with my stuff, but the layout existed and worked out. So that 2-speed I mentioned earlier didn't shift very well. I wanted one that I could shift under load with no problems. So the pictures could be a little brighter, but if you notice, there is a pulley here, so a motor would mount here. There's a solid shaft across the top, and there's 2 chain runs. One of them is conventional, and it's 2 sprockets with a chain around the outside. The other one's a little funky, because it comes around the top, but then it comes around the opposite side of that sprocket below. And then there's an idler here, and then it goes back around to the top up there. So it kind of looks like a weird L. Both of these bottom sprockets are on ratchets to the back axle. So this is a 2-speed transmission. With what I just said, can anybody besides Brian tell me how it shifts? And you, Steve. There's no extra actuator. This is purely just a motor driving this. Okay, so there's one conventional chain run, so sprocket, sprocket, normal chain run. Yeah. There's another one where it's the same 2 sprockets, but then there's 2 more, so the chain comes around the top, around the other side of that sprocket. So from the one up top, it goes around this way, idler, idler, back up. Since both those sprockets are on the bottom, and one chain run comes around one side of the normal side of its sprocket, and the other chain run comes around the opposite side, it means when you spin the axle on top forwards, one of those sprockets is moving this way, and one of them is moving this way. The 2 sprockets on the output are moving in opposite directions. So in this instance, whichever one is rotating, and both of the ratchets go the same direction, so whichever one is rotating forward is driving the back axle. The other one's just moving backwards and freewheeling just like your bicycle. So you shift the transmission on this thing by taking your motor and spinning it the other direction. So I'm driving full speed, push a button, motor flips the other direction. The motor's now spinning completely the opposite direction, but I'm moving that way faster. This works in a tiny go-kart because you don't need to go backwards. You shouldn't need to go backwards unless you stuff it into a wall. But effectively, this gave me a free, very easy to actuate 2-speed transmission. And the biggest downside to it was if the cart's sitting there, you cannot push it backwards. Both ratchets lock and it pulls against both chains, and you cannot roll backwards. You have to pick up the back of the cart, slide it backwards, set it down. But if you can take a guess, this has been used elsewhere, and it turns out it's 1930s bicycle technology. Before derailleurs were popular on bicycles, it was either single speed and then people trying crazy stuff. So in this case, it's a single chain run, but if you follow this chain run around, the top chain comes over the top of this sprocket, around the big guy, back, over the top of the other sprocket, up around an idler, and then back to the other side. So a chain actually has some flex to it, so you can have things a bit misaligned and it works out. But it's a two-speed where you pedal forwards, you're in one gear, you pedal backwards, you're in another gear. It's made by a guy, it was made by a guy called La Hirondelle, but you can Google RetroDirect two-speed and find more details on that. But it works perfectly fine for a bicycle, and I've been tempted to build one just to have it. But you don't need to roll backwards on a bicycle, so it works fine. And who really cares if you pedal backwards? Like, it's just weird to get used to. And then this is a more modern take somebody did on it where they put two chain runs, but one of them they flipped, and you can't really see it, but there's a clear piece of plastic in here just to keep those two chains from directly rubbing on each other. But it's achieving the same thing of my funky sprocket runs on the other one. I just didn't want to have to run chains past each other and flex them out of the way. So, 1930s bicycle technology. Still can be used for stuff. And it turns out the better solution is just to make your own motor controller so you can dump enough power where you don't need two speeds. Which is what we did later in the tiny van that I was driving around. So, recapping some of the methods I went through there. I make sure to entertain almost all ideas. Monkey wrapped in tinfoil, still dumb. That comes from a friend of mine in high school who just, that was all he ever said during design input stuff. So, but that means sometimes I'll catch people say, oh, never mind, that's dumb. And anytime I hear anybody say that, I'm like, stop and spit it out, because somebody else can have a good idea based off of it. And then part of that is like, yeah, if you're trying to be that level of open, you're not allowed to badmouth anybody. You're like, oh, that's dumb. That's dumb. Don't tell them that. But entertaining almost all ideas that come up. And thinking through them real quick. Even if something sounds stupid, give it some thought. Let your brain run a little. And the second one of during brainstorming, letting your mind wander when you sense a spark. If somebody is explaining something to you that you didn't understand, and you gain understanding and just go, oh, what if, and let your mind wander. I'm perfect, like if I'm having a conversation with you and you do that, I'm perfectly fine with you saying, sorry, I was thinking about something else. And letting your mind initially take that and run with it versus trying to store it for later and go back to it. And the third one's one of the most entertaining when it happens. Somebody will have an idea, they'll start explaining it to somebody, and that other person will completely misunderstand it entirely and somehow end up with a better idea. It has happened before. It is quite entertaining when it does. But sometimes having no idea what the other person's talking about and just trying to piece it together, you end up with a different thing that might be useful in the future. This one is, some people agree, some don't. And it's hard to do at the beginning of a build season because you're hyper-connected with regards to you can pop out your phone and chat with whoever you want, whenever you want. But giving your brain time to just think and do some mindless stuff, it's cleaning, like I like rock climbing, like I don't need to be thinking that hard about it, of just giving your mind time to wander. And then the last one, which you saw me bring up a bunch, find existing technologies that could be applied to your problem. Because the amount of problems that have been solved out there is a very, very, very large amount, and chances are one of them is pretty close to what you're trying to do. So, yep, this is another one. Sometimes you're creative and decide to go for something. You need to make sure everyone's on board with it. Otherwise, if something doesn't work out, people start playing the blame game. So that's a conversation you get to have up front ahead of time, make sure everyone's on the same page. This was a conversation we had this year when we went for a double jointed arm. It's like, all right, we're doing this? Everybody good? All right, this is not going to be as straightforward as an elevator with a roller claw setup. So everybody's got to be on that same page. And make sure you own up to your reasoning. If you did something and you did it purely because you wanted to have fun doing it, you're allowed to say that. Don't try to sugarcoat and BS your way through, oh, it's better because blah, 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 blah. No, you need to be objectively looking at the output and going, all right, we did pretty good, but an elevator was still the right call. As far as be true to yourself on that one. That's part of the analyzing the benefits really hard. Because like this season, I personally think we ended the season with a robot on 971 that was capable of doing everything the 254 robot could. But they had a robot that was done earlier and more streamlined because they weren't doing any new dev and their construction process was more straightforward. So we ended up losing out on a lot of the time resource due to doing the more complex approach to it. So, and then this last one, have fun. You're in a high school robotics competition. Nothing is the end of the world. At no point in time, like if I ever see anybody raising their voice, yelling at anybody, it's to remind them, hey, you're in a robotics competition with high schoolers. Like this may be the biggest thing in the world to you right now. It's still just a competition. It doesn't really have any huge bounding. Like how well you do in a competition isn't that big of a deal as life goes on. Build fun stuff. Like just the more you build of it, the more experience you have to draw on, the more things you can pull from. I just started building stuff back in like middle school and earlier and just have never stopped and just have a very long list of projects and experiences. And it makes it a lot easier to go, ooh, new problem, and have this bank of experiences behind me that I can pull from and know that doesn't work at all. Okay, that's going to be a pitfall I'm going to hit there, and various approaches to things. And you just got to start doing it with regards to start gathering projects and get to know other people who also do the same, because if you do it right, you can start learning from all of their experiences. And you can, a lot of the things I showed, those weren't just me. That was a team of people working on those things. And a lot of those was a lot of discussions and a lot of back and forths. And more brains working on a thing is more power working on that thing. And you can build up all the experiences you want. There's always more. So that is my recap on that one. And that puts me at the end of this. So, anybody have any questions regarding some of my approaches or anything I showed or anything else you would like to know? Yep.
What's the stupidest thing you've designed that worked?
That's, you got to define worked.
Like it functioned, it did what you wanted it to do.
All right. It's going to take me a bit. Anyone else have anything in the meantime?
What was your favorite project?
The question on that one was, what was my favorite project? I find myself more recently, a lot of my fun side projects are things that let me work on a project with other passionate people. So I end up with, like one example of BattleBots, Brian actually helped out a fair amount, and I've got a bunch of other, Austin helped out, and a college buddy in San Diego, a former coworker in Texas, who now lives in Michigan. The most fun I have on projects is usually related to the people working on those projects. So like the tiny hilarious go-karts are just pure fun. Like I can go to a race, lose a wheel, lose another wheel, don't finish that race, darn, nothing matters. Like there's literally nothing on the line. And that one's fun because it's just being treated as the de-stress, yep, all right, quality control, see how it goes, approach to things. So the Power Wheels racing has been one of the most fun things because of that, and there's no stress, you're not sitting there trying to appease sponsors, you're not trying to like show off and get your school to the top of the pile for competition and stuff. It's just straight up fun. And it's with a whole bunch of people at the competitions who are just as fun. Like at an FRC competition, if you go to somebody else's pit and ask for help, they'll help you. The exact same thing in a pit full of people building Power Wheels cars. And exact same thing in people in pits at BattleBots. As far as if you need something, somebody will hand you a $400 motor. Like, it's like, okay, because you needed it. And the same level of helpful. So like BattleBots filming this year was a 2-week-long thing. I had 2 straight weeks of being down in a hangar in LA, being 20 minutes away from a McMaster warehouse, So from a creativity perspective, it's a little too big when you're like, all right, I can just go get McMaster in 20 minutes. That was essentially a 2-week experience at the actual competition of hanging out with a whole bunch of like-minded people. Every single one of them has a different instance of projects and a number of robots they've built, and talking to all of them. Those are the most fun things. So, and then I have a large group of networked friends from FRC stuff. I got my first job out of college due to my FRC involvement. And then I got a job out here due to my FRC involvement of knowing people. So I would say the most fun I've had on projects is just getting to know more and more people and learn about their experiences as well. As far as your question of which one I'm surprised it worked, that's still really hard. At one point in time for a 4-H project in middle school, decided to build a tank. And that one ended up, I took 2 snowmobiles and bolted them side by side with a chair in the middle and some hand controls, got rid of the skis, and had 2 very large casters up front. That one stretches the definition of worked, because it moved under its own power once, and then we just said never again. So that was stupid, but I was a middle schooler, and my dad just went, I'll let him keep going. Other questions? Yep.
What's the name of your battle bot?
Oh, sorry. Tantrum. It's been in 1 fight so far, and I got to fight a giant cheeseburger. Battle Royale with cheese. It had a spinning bacon blade and 2 large AR-400 buns. And the funny part is, I knew everybody on that team already, because the guy who started the Power Wheels Racing League was on it, and a bunch of other people who built Power Wheels cars were running that team. So I got to face them. Yeah.
Did you know the crazy people like dancing in those mustard costumes?
Yeah, that was them.
Oh, that was?
That's, yeah. The guy who did all the graphics for that is the one who started the Power Wheels Racing League. So I actually saw a bunch of them a couple weeks ago in Detroit, because we loaded up 2 carts, shipped them on a pallet to Detroit, and competed. So there's a lot of entertaining overlap between things. So, thank you for your time.